So hello and welcome in this video on two-dimensional discrete random variables. So we are having this two-dimensional discrete random variable, and today's topic is the expectation of two-dimensional discrete random variable, right? So when we are having this two-dimensional discrete random variable, so there is a possibility that we have to calculate the joint expectation, which is the expectation of xy, and we are also having the expectation of the individual variables, which is the expectation of x, expectation of y, and we are also having this the conditional expectation of x given y and y given x. And in order to calculate these expectation, we have to use the probability. So this is the joint expectation. So here we will use the joint probability of a pair, right? In order to calculate the individual expectations of the variable, we will use the marginal probability or marginal probability distribution, and here we have to use the conditional probabilities to calculate the conditional expectation. Okay, so here we have to find out the steps involved in the calculation of these expectations. So we will illustrate this with the help of an example here. So let us consider an example, and in this example we are provided with a distribution of two-dimensional discrete random variable. So the distribution is given as this table, and in this table we are having the values of the two random variables, so that is x and y, and the values of x are 1, 2, 3 and 4, and same values we are having for the variable y. And here we are having the probabilities. So the probability is 1 by 16. So this is the probability corresponding to the pair x is equals to 1 and y is equals to 1. And we are having the probabilities as 0, 0, 0. Next we are having the probability as 1 by 16 and 2 by 16. And the remaining probabilities are 0 here. Next we are given 1 by 16, 1 by 16, 3 by 16 and 0. Now in the last we are having the probabilities as 1 by 16, 1 by 16, 1 by 16, and lastly the value of the probability is 4 by 16. So we are given this table, and with this help of this table we will find out the probabilities, the expectation of the two variables. So let us consider the first the joint expectation. Okay, so here we have to calculate the joint expectation. So the joint expectation, as we are discussing that this is nothing but the expectation of xy, which can be calculated using this double summation. So here we are having xi yj multiplied by their corresponding probability. So what we are having here, these this is a pair, means you are picking a particular value of x and a particular value of y, and you are multiplying these three quantities, means the value of x, the value of y and their joint probability. So using this formula we can calculate this. So suppose you are finding the first value of x, which is 1, and the value of y is 1. So the first values are 1 and 1, and you can see that the probability corresponding to this pair is 1 by 16. So this is 1 by 16 plus, now it will be good if we keep this x fixed at 1, and we will take all the values of y corresponding to this x is equals to 1. So we are keeping this x as 1. Now the next value is of y is 2. So this is 1 into 2, and the probability corresponding to this is 1 by 16 plus, next again we are keeping this x at 1, and the next value of y is 3. So this is 1 into 3 multiplied by 1 by 16 plus, again x is at 1, and the next value of y is 4, and the common probability is 1 by 16. Next we will move towards the next value of x, which is 2. So this is 2, and again we will take all the values of y corresponding to this x is equals to 2. So the first value of y is 1, and the probability is 0 plus 2, and the value of y is 2, and the probability for the same is 2 by 16 plus 2 multiplied by 3, and the probability corresponding to this is 1 by 16 plus 2 multiplied by 4, and the probability is 1 by 16. Next we will have the value of x at 3 multiplied by the first value of y, which is 1, and the probability for this is 0. So this is 0 plus x is still at 3, and the next value of y is 2, and the probability is 0 plus x at 3, y at 3 multiplied by the common probability, which is 3 by 16 plus 3 multiplied by 4, and the probability is 1 by 16, right? Next we are having the last value of x is 4 multiplied by 1, and the probability of this is 0. And next we are having 4, means the value of x is at 4, and the next value of y is 2, and the probability for the same is 0. Next we are having the value of y as 3, and the probability is 0. You can check here. So this is x is equals to 4, and this is y is equals to 3, and the probability here is 0. Okay, so lastly we are having x is equals to 4, y is equals to 4, and the probability for the same is 4 by 16. So when you multiply all these values, so you will have the first value is 1 by 16 plus the next value is 1 by 8 plus the next value is 3 by 16 plus we are having 1 by 4. So these are the first 4 values here. Now the next value here is 0. Okay, so you can see that this is 0 because this is multiplied by 0, and here you are having 2 into 2 into 2, which is 8 by 16. So this is 1 by 2. Next we are having 3 by 8 plus we are having 1 by 2, and for the next row we are having 0 plus 0 plus 27 by 16 plus we are having 3 by 4 plus 0 plus 0 plus 0, and this is 4. So when you add all these values, the expectation or the joint expectation is coming out as 135 upon 16. So this is how we can find out the joint expectation of the two discrete random variables. Now in order to obtain this expectation of x or expectation of y, as we discussed, that we need the marginals. So let us first find out the marginal probabilities. Okay, so or it will be good if we make a separate table. So now we are considering first the marginal distribution for x. Okay, so this is the marginal for x. So here we are having, in this table we are having the values of x and their corresponding marginal probabilities. So we are having 4 values here. So the values are 1, 2, 3 and 4. Now if you look at this x is equals to 1, so there are 4 probabilities corresponding to this 1 by 16, all have the same values. So when you add, so this is coming out 4 by 16. Now corresponding to 2, we are having again 4 probabilities, out of which the first one is 0, and when we add remaining 3, so we are getting 4 by 16. Next we are again having 4 by 16, and similarly we will obtain the marginal probability for x is equals to 4. Now on the same line we will calculate the marginal for y. So the marginal for y, so again we are having a table, and in this table we are again having the values of y. So the values of y and the corresponding probabilities. So here we are having the 4 values, and the values are same as the values of x. And now we have to add the probability corresponding to the different values of y which are given along the rows, because this is the value of y, which is the first value of y, which is 1, and we are having 4 probabilities here. So out of which 3 are 0. So when you are adding, so this is coming out 1 by 16. The next is 3 by 16, and the next value is 5 by 16, and lastly we are having 7 by 16. So this is the marginal for y. Now we will use this marginal to calculate the expectation of x and y. We will use the marginals corresponding to x and y. Okay. So so first we will calculate the expectation. So the expectation of x, or you can also say that this is mean of x. Okay, so this is mean of x. So the formula is same as that of the one variable, that is x px, only changes now we have to use this px, which is marginal corresponding to the different values of x. So these are the marginals. Okay, so now we will start with the first value, which is 1, and the marginal corresponding to the x is equals to 1 is 4 by 16. In fact, for x you can see that all the values of x has the same marginal probability, which is 4 by 16, 4 by 16, so on. So this is 1 into 4 by 16 plus the next value is 2, which again multiplied by the same value, which is 4 by 16 plus 3 into 4 by 16 plus 4 into 4 by 16. So when you combine all these values, so this is coming out as 5 by 8, which is the expectation of x, or you can say the mean of x. Now suppose we have to calculate the variance of x also. Okay, we have to find the variance of x. So we know that the formula of variance of x will be expectation of x square minus expectation of x whole square. So out of these two values we have already calculated expectation of x. So in order to find the variance of x, we need to find out the expectation of x square. So we have to find this quantity, and once we are having these two values, we are putting here and we will calculate the variance, or you can say the standard deviation also. So this variance of x can be represented as sigma x square. So expectation of x square is simply defined as summation x square px, which is very much similar to the case of one dimensional random variable. So we will again having the probabilities as same. All we need to do is squaring the different values of x. So the first value is 1, so square is same, and this is 4 by 16. Next we are having 4 multiplied by 4 by 16 because the square of 2 is 4. Next is 9 multiplied by 4 by 16, and lastly we are having 16 multiplied by 4 by 16. So when you add up all these quantities, so expectation of x square is coming out as 30 upon 16, or you can say 15 upon 8. Now in order to find the variance, we will put these values here. So we are using this formula. So we are having expectation of x square, which is 15 upon 8, minus expectation of x whole square, which is 5 by 8 whole square. So this is coming out 15 by 8 minus 25 by 64. So after simplifying the things, you will obtain this variance of x as 1.09. So this is how we can find out the variance of x. Next we will find out the expectation of y. So expectation or again mean of y, or we will also discuss the calculation of variance. So expectation of y can be calculated using the marginal. So again the formula is summation y py, and when you are having the marginal, we already calculated the marginal here. You can see that this is the marginal distribution for x. So we will use these marginals. So the first value of y is 1, and the marginal corresponding to this is 1 by 16, plus the next value of y is 2, and the marginal is 3 by 16, plus the next value is 3, and the marginal corresponding to this 3 is 5 by 16, and lastly we are having the value of y as 4, and the marginal probability corresponding to this is 7 by 16. So when we are adding all these values, so expectation of y is coming out as 50 upon 16, or you can say that it is 25 upon 8, or you can say the mean of this variable y is 25 by 8. Next, suppose we have to calculate the variance of y. Okay, so the formula of variance of y is same as expectation of y square minus expectation of y whole square. So all we need to do is find out the value of this expectation of y square, because we have already calculated the expectation of y, which is 25 over 8. So expectation of y square is simply summation y square py. Again this py is the marginal. So we are having 1 multiplied by 1 by 16, plus the next value is 2, and the square of the same is 4, multiplied by 3 by 16, plus 9 multiplied by 5 by 16, plus 16 multiplied by 7 by 16. So when we add all these values, so this is coming out as 170 over 16. Now we know that the variance of y is expectation of y square minus expectation of y whole square. Okay, so we have to obtain this variance of y, and we are putting this value here. So this is 170 over 16 minus 25 by 8 whole square, and this is coming out as 1.25. So this is how we can obtain the variance of y, or the mean of the random variables. Now related to these expectations, we are also having the another concept, which is the covariance. Okay, covariance of x and y. So the covariance of xy, which is defined or which is represented as covariance xy, now this can be calculated again using the expectations. So here we are having the joint expectation and multiplied by the individual expectation of the random variables. So this is our formula, and as we already calculated the values of the joint expectation and the individual expectations, so the value, while putting the value here, we can calculate the covariance as 135 upon 16, which is the joint expectation, multiplied by 5 by 8, which is the expectation of x, and multiplied by expectation of y, which is 25 upon 8. So this is coming out as 6.48. So this is our covariance, right? This is our covariance of the two random variables x and y, and we know that covariance of x and y may be covariance of two random variable is maybe positive or negative. There is no fixed concept that it is always positive or always negative. Now if we are having if, so this is a remark that if x and y are independent, then their covariance will be 0. Okay, covariance of xy will be 0, and this is can be represented as, means if the covariance of xy is 0, so this means expectation of xy minus expectation of x multiplied by expectation of y is 0. So you can write this as expectation of xy, which is the joint expectation, is the product of their individual expectation. So this is how we can calculate the covariance. And however, there is a very important remark, means if you are getting, if covariance of xy is 0, then we cannot conclude that this does not implies that x and y are independent. Okay, in fact we have to mention that if this covariance of xy is 0, so this simply means that x and y are uncorrelated. Okay, so this simply means that x and y are uncorrelated, and yes, and this is the covariance, means how we can find out or how we can calculate the covariance of two random variables. And suppose you have to calculate, in the beginning we will also discuss about the conditional expectation. So here you can see that conditional expectation. So the conditional expectation can be obtained by using the conditional probabilities. So here we again use this same table. So let us discuss about the conditional expectation. Conditional expectation. or we can say that conditional mean. We can talk about conditional expectation and conditional mean. So this can be calculated, means suppose you have to find out the expectation of x given some values, a particular value of y. So this can be obtained by multiplying x with the conditional probability of x given some given the same value of y, right? So we will discuss this in detail in our next video. So for this video, that's all, and please watch our next video in which we will talk about this conditional expectation in detail. That's all.